Hello, welcome. This is lesson 8.2 on simple polynomial and rational inequalities. I'm going to go through a few examples here and then you'll have a chance to practice on your own. When solving rational inequalities, you set any part of the fraction that contains a variable equal to 0. Then test the intervals to see which sections of the function satisfy the inequality. Graph the solutions on a number line and write in interval notation. Let's see if we can make that a little bit clearer here with this first example. We have 1 over x minus 5 is greater than 0. And so in this case, the only part that has the variable is the denominator, x minus 5. And so we would say that x minus 5, because it's in the denominator, whatever value makes this equal to 0, it can't be that because you can't divide by 0. And so we would say x minus 5 is not equal to 0. And then we solve this just like an equation. And we add 5 to both sides. Therefore, x cannot be equal to 5. Now, I want to make note of the fact that this says that this expression has to be greater than 0. And greater than 0 means that it is positive. Also, the bottom, the denominator, is always an open circle. And cannot be equal to 0. So we go down here, let's just choose a point, we'll call this 5. And as I said, it must be an open circle there at 5. So then we do a sign chart like we did in the last lesson, if you'll recall, in 8.1. So anything to the left of 5, this would be negative over here, and anything to the right would be positive. And because we are looking for the expressions where this is greater than 0, which is positive, our solution set goes off to the right. So we shade off to the right, and we can include a little arrow at the end to say it continues to go to the right. In interval notation, we would write that this is, it starts at 5. We use a parenthesis at 5 instead of a bracket. The bracket would show that it could be equal to 5. That it could be equal to 5. And as we see, it's x is not equal to 5. So this goes off to the right until we get to positive infinity. And we also use a parenthesis there. On the next example, we've got 2x plus 1 over x minus 3. And this is less than or equal to 0. So if we take 2x plus 1, we set this equal to 0. Subtract 1 from both sides. We get 2x is equal to negative 1, and then divide by 2. Both sides, then x is equal to negative 1/2. We also need to take the denominator, x minus 3. But this time we need to make sure we say that it is not equal to 0, because if it was equal to 0, you'd be dividing by 0, and you cannot do that. So we add 3 to both sides, and x then cannot be equal to 0 plus 3 is 3. So x cannot be equal to 3. So we go down to our number line and we graph these. I'm going to put a point here for 0 for reference. 1, 2, 3, and at 1/2, between 0 and 1, I'm going to mark that that's 1/2, and then I'm going to mark it just a little bit bigger. And then at 3, we use an open circle, and then we need to make a a chart thinking about these different spaces here. At 1/2, to the left of that, we'd have negative. To the right, positive and positive in the other two intervals. And then 3, to the left of it, we'd have negative, negative, and then to the right, positive. And then we multiply out the signs. Negative times negative is positive. Positive times negative is negative. And positive times positive is also positive. When we look at, go back to our what our original problem was, then the expression had to be less than or equal to 0. Now less than 0 is negative. And so we look down here, and the only place where it's negative is right here. So we shade in between, and that's our solution set, is between 1/2 and 3. In interval notation, we would write that this is, it goes from 1/2, and at 1/2 we write a bracket, because this time it can be equal to 1/2. And then we put a comma and 3. Now it can't be equal to 3. It can be equal to 2.9, 2.99, or 2.999, but it can't be equal to 3 itself. So we use a parenthesis to show that it cannot equal to 3. And that would be what our solution looks like in that example. The second part deals with when solving polynomial functions. And for this, you solve the numerator and the denominator for x. And then you find intervals that satisfy the inequality by seeing what is above the x-axis for greater than, or below the x-axis for less than. Then you graph the solutions on the number line and write in interval notation. Let's take a look at what that looks like. In this first example, we're going to take x squared minus 5x minus 6, and we're going to factor that out. So x squared minus 5x plus 6. And we could write out the box and a number of different graphic organizers to help us factor this, but I like to just go straight to the parentheses when we're going to have two sets, because it's a trinomial. X times x is x squared. And then I'm looking for two numbers that multiply to give me positive 6 that would combine to give me negative 5. And that would be 3 and 2. They'll both be negative in order to make the negative 5x that's in the middle. So negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. And we're going to set these equal to 0, which means that each of these factors would be equal to 0. So we say x minus 2 equals 0, or x minus 3 equals 0. And if we add 2 to both sides in this left equation, then we get x equals 2, or x minus 3, adding 3 to both sides, we get x equals 3. And then we also need to take this x minus 4 on the bottom. Once again here, this x minus 4 cannot be equal to 0. So we solve it as though it's an equation, but it can't be equal to that number that would make that 0. So adding 4 to both sides gives us x cannot equal 0 plus 4, 4. So x cannot equal 4. So then we go down to our number line, and we graph 2. And I'm going to skip a space here, 3. And at 4, also number line there, 4. Now, I used open circles for all of these, even though up here I put x equals 2 and x equals 3. When I put 2 in here for the numerator, that sets it equal to 0. And this greater than 0 does not allow for it to be greater than or equal to 0. And so we use an open dot in each one of these places. So then I go through and I make a sign chart to help me decide where to put my solution set here for this inequality. And use a little color. So for 2, to the right of 2, to the left of 2, sorry, it would be negative. To the right would be positive, positive, and then positive in each of those intervals there. For 3, to the left of 3 it would be negative, negative, and then to the right positive. And then for 4, to the left of 4 would be negative, 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 and to the right positive. And if we add these all up, negative times negative is negative, times negative again would be, I'm sorry, negative times negative is positive, excuse me. Positive times negative would be negative. So this is a negative in this interval. Negative times negative is positive. Positive times positive is positive in between 2 and 3. And then we have negative times positive would be negative in between 3 and 4. And then finally, to the right of 4, positive times positive is all positive. So if we go back up to the top, noticing that this is the whole inequality here, or the whole expression on the left has to be greater than 0, that would be positive. And so we're looking for the intervals where this is positive. So we can shade in between 2 and 3, and then it's also positive to the right of 4. And so in our interval notation, we would say that this is between 2 and 3 with both of their parentheses. And then there's a space in between them, and we want to join all of the union, so we put a U in between them to show that there's a union of those sets with 4 that extends to positive infinity. And that would be our solution in interval notation. This last example, we've got x squared times x minus 5, and then it's all over x plus 4 raised to the third power. So even though we've got x squared as a factor twice, we basically just have 3. Even though x plus 4 is raised to the third power, we have that as a factor 3 times. We really just have the 3 factors, so we can just look at this as those 3 numbers. So first of all, x squared equals 0. And if I take the square root of both sides, then x equals 0. And so x equals 0 is one of our numbers. Then we take x minus 5, set that equal to 0, and add 5. Then x equals 5. And then finally, if we go to x plus 4. In this time I'm going to ignore that cube that's outside of it, because whatever makes x plus 4 0, it's going to happen to each one of those three factors the same way. So I'm going to take x plus 4, and I'm going to say this time is not equal to 0. So then I solve this like it's an equation, subtracting 4 from both sides. X is not equal, 0 minus 4 would be negative 4. Actually, the same is true for the top two numbers as well, 0 and 5, because this is strictly less than 0. It doesn't say less than or equal to. So something that's less than or equal to 0, that would be negative. And so we go down to this number line, choose some spots. Let's call this 0. We go 1, 2, 3, 4, and 5. Oh, I didn't leave myself enough space. So let's rewrite that. 0, 1, 2, 3, 4, 5, and 1, 2, 3, 4. There's negative 4. And so then we're going to have open circles in each one of those. And then we make our sign chart, taking each one as though it's the center, to which to the left would be negative and to the right would be positive. So to the left of negative 4 would be negative, and then positive to the right, positive, and positive. If we look at 0, to the left of 0 would be negative and negative in each of those intervals, and positive to the right. Positive, positive. And then for 5, to the left of it would be negative, negative in each of those intervals, and then positive to its right. And then negative times negative times negative. If you have an odd number of negatives, you get a negative result. So that would be negative. And here you have two negatives. That's positive. Here you just have one negative, so that's negative. And then you have three positives, which would be positive. So focusing in back on what we were looking for, since the expression is to the left and it's less than 0, that's going to be negative. Then our intervals where we're going to have our solution is to the left of negative 4, and then here negative in between 0 and 5. And so our solution would be from negative infinity to negative 4, parentheses on both of those, union 0 to 5. And that would be our solution in interval notation. And this would be its graph, as we see down here. So that's it. Thank you for watching. Now go try some on your own. If you show up to one of our weekly meetings, then you can get some help. Miss seeing you guys all in person. I hope you're all doing well. Thanks. Bye.